They don't even answer problems correctly. Yeah, yeah. Yeah, today's, yeah. I need to know that you know to do both. Okay.
Sorry, I wanted to.
Can my kids please listen?
Talking to.
Hey, if I work to teach you, you work to let me know that you know how to do it. Okay. So, I'm going to make cheese sandwich. I have 2 slices of bread. Okay. I have 3, let's say this is Swiss cheese. Pardon my drawing, Natalie's laughing at me. She is autistic and she finds it really funny. Alright? How many sandwiches can I make? If my recipe requires 2 bread slices, or let's make actually 4 bread slices. If my recipe calls for 2 bread slices and a cheese in between, and I have 4 bread slices and 3 cheese slices, how many sandwiches can I make? 2. What limited the amount of sandwich I could make? What is that? How my recipe calls for 2 bread slices and a cheese slice in between. How many bread slices do I have? 4. How many cheese slices do I have? 3. How many sandwiches can I make?
2.
What limited the amount of sandwich I could make? Bread. So my bread is my limiting reactant. Bread is my limiting reactant. Because it limits the amount of product I can make. Do you understand? What is the reactant? The one that you start a reaction with. Do you understand the word vocabulary reactant? A reactant is not a product. Remember that, right? So the bread is the limiting reactant because it limits the product that I can make. My cheese is my excess reactant. Are you with me? So now you're going to calculate in your problem which is your limiting reactant, alright, and how much of the excess reactant will be left behind. Does that make sense? You need to do such calculations. In this case, 1 slice of cheese will be left behind after you make 2 sandwiches. Yes or no? Now, the mole ratio was already given to us. The problem is we are not given moles when we work with substances. Instead, we are given the mass in grams. Yes or no? So if you are given the mass in grams, how do substances react though? In what ratio do they react? In mole ratios. So unless we convert the grams into moles, we cannot find out which is the limiting and which is the excess reactant. Does it make sense? Okay? So a limiting reactant is a substance that runs out in a reaction, and when it is gone, the reaction stops. You will know that a problem, not a 5-step necessarily, is a limiting reactant problem when because the values for both reactants are given. Okay? So I know it says 10 grams of aluminum reacts with 35 grams of chlorine. The mass of both the reactants are given. Does that make sense? I know that this is a limiting reactant question. I need to write my reaction first. aluminum combines with chlorine, what is the type of reaction? If you have a metal and a non-metal, synthesis, what is the product? What is the product? Metal plus non-metal, what is the product? AlCl, AlCl2, AlCl3, what is the product? AlCl3. Alright? Let's balance the equation. Alright? That's a 2, that's a 3, and that's a 2. Right? Or should I make it a different color? 2, 3, 2. Now, what are you given? You're given 10 grams of aluminum, and how many grams of chlorine are you given? 35 grams of chlorine. The question is, you have to determine which is your limiting reactant. Can you just look at 10 grams and say 10 grams is the limiting reactant? Because it's lesser in amount? What do you have to convert your grams first into? Moles, because they react in mole ratios. Alright? So let's find the number of moles of both Al and Cl2. So I have 10 grams of Al. I want to cancel out of grams of Al and make it into moles of Al. Guys, when you do limiting reactant, excess reactant problems, there are a couple of ways in which you can solve this problem. In math, there are many ways you can reach your solution. Is that right? And I'm going to teach you one of the ways in which you can solve the problem. Is that understood? Okay? There are a couple of different ways. I'm going to teach you one. So what is the molar mass of aluminum? 26.98, sorry for that, is 1 mole. How many moles of aluminum do you get? 10 divided by 26.98. Yes, Natalie? I can hear you. 0.3706. Let's make it 371 moles of aluminum. Are we good? Are we good? Let's find out the moles of chlorine. Remember it's Cl2. So 35.0 grams of Cl2. What number will I divide it by? What will I divide it by? 70.9. Why? Because it is Cl2, which is 1 mole. Thomas, can you give me what is the number of moles of aluminum? When I divide 35 divided by 70.9, can you give me the answer? Point 493 moles of Cl2. Guys, I just found the number of moles of both my reactants. Please remember, they react in the ratio 2 to 3. Because they react in the ratio 2 to 3, I yet cannot conclude which is my limiting reactant. The ratio is not 1 to 1. If the ratio had been 1 to 1, this is the lesser amount, and I can conclude that it's 0.37 moles is the limiting reactant. Does that make sense? Because the ratio is not 1 to 1, it's 2 to 3, there is one additional step you have to do. To decide which substance is limiting, you must divide each substance, each moles, by its own coefficient. Whichever comes out lesser is your limiting reactant. And it is this amount that you use for step number 4, which is to find out how much of the product I can make. So, what do I do next? Alright, so what do? I do 0.371 divided by 2, and I do 0.493 divided by 3. Can you tell me what is the answer in each case? Yes, Natalie. 1855. All right, 185, 186, and
CL2 is 0.1647.
1647 is 5. Are we good? Which is lesser now? Therefore, this is my limiting reactant. This is one of the ways to approach the problem. Do you understand? Convert it to moles, divided by the coefficient, whichever comes out less is your limiting reactant. That's one way to approach the problem. Are we good? Okay, so now, did my number of bread slices decide the number of sandwich I can make? Yes or no? So the limiting reactant will decide the amount of product I can make. If I ask you, okay, how much of aluminum chloride will I make? Can you start with 10 grams of aluminum to do your problem? That will be enough. I can't start with 3 cheese slices and say, hey, I'll make 6 sandwiches. You'll run out of bread. Right? So you always, in order to determine the amount of product formed, you always start your calculation with your limiting reactant. Okay? So which is my limiting reactant? My limiting reactant is 35 grams of chlorine. Can I find out the number of moles of aluminum chloride it will make? Grams of chlorine should be converted to moles of chlorine. Moles of chlorine should be converted to moles of aluminum chloride, should be converted to grams of aluminum chloride. Correct? Yes? I cancel out of grams of chlorine. I cancel out of moles of chlorine. I cancel out of moles of aluminum chloride. Grams of chlorine is 70.9. That gives me 1 mole. How many moles of chlorine give how many moles of aluminum chloride? That. What was the coefficient, guys?
3 on one and 2 on
3 on this and 2 on that. And then 1 on this. What is the molar mass of aluminum chloride? 26.98 plus 3 times. Anybody has an answer? Anybody has an answer?
133.33.
This is 133? 133.33. And then what is your final answer? How much of the product can I make? How much? Is everybody getting the same answer? 43.88 is 43.9 grams of AlCl3. Is that right? Is that right? So one of the ways you find the limiting reactant is find the number of moles and divide by the coefficient. Is that right? Another way to do this problem in order to find the limiting reactant is, what you can do is, you know how you're given 35 grams and 10 grams of aluminum? Is that right? You can do one more calculation. You can start with 35 grams and you can also start with 10 grams of aluminum and do the calculation. Alright? So 26.98 grams of aluminum is 1 mole of aluminum. And then how many moles of aluminum react to give how many moles of chlorine? 2 moles of aluminum react to give, no, that doesn't, 3 moles of aluminum react to give 2 moles of aluminum chloride. Is that right?
No, it's 2 moles.
2 moles of aluminum. Okay, so 2 moles of aluminum gives 3 moles of aluminum chloride, and then 1 mole of aluminum chloride is, what was that number she gave me? 133?
Yeah, 133.33, but it should be
133.33.
It should be
Two
2
moles
on
of aluminum
top.
chloride.
Like moles of aluminum.
Is this also 2?
Yeah.
Okay, so then what is the final answer? What is the final answer? It's not the same. I started with 10 grams of aluminum. What is the final answer? What is 49.42 4 grams of AlCl3. So the other way you can find a limiting reactant is, it's almost as if I'm starting with 4 bread slices and I'm finding how much sandwich I can make. I'm starting with 3 cheese slices and I'm finding how much product I can make. In which case did you make lesser product? In which case? With 10 grams of aluminum or 35 grams of chlorine? 35 grams of chlorine. So you can decide the lesser will be the amount of product formed, and whichever reactant makes lesser of the product will be your limiting reactant. Do you understand? This is another way to do the problem. Just use the starting grams of both your reactants, solve for the product, whichever comes out less is your limiting reactant. Do you understand this? Do you understand how to do a limiting reactant problem? Okay. The next one is, how will you find out how much of the excess reactant is left behind? Can you please take out a piece of notebook paper? If you don't have enough space there, can you take out notebook paper? All right? How much of excess reactant is left behind? All right? How much of excess reactant is left behind? What are reactants? Where will we find reactants? Before the arrow or after the arrow? Before the arrow. What are the 2 reactants in this case? The 2 reactants are 10 grams of aluminum and 35 grams of chlorine are the reactants. Yes or no? Which was our limiting reactant? How did we decide which was the limiting reactant? We can do it any one of the 2 ways. Is that right? We can convert to moles, or we can find the product and we can find out whichever is lesser. Which did we decide was the limiting reactant? Did we decide that this was the limiting reactant? Correct? So if I'm given 3 cheese slices and 4 bread slices, for every 1 cheese I need 2 bread. Is that right? So what is the excess reactant left behind? My cheese, which is 1 slice. Correct? So you can do how much of the excess. So this is the excess left behind. Right? How do you find out how much of it is left? You can do from the limiting reactant to the excess reactant, you can do a gram A to gram B problem. Do you understand? So how do you do a gram A to gram B problem? You have 35 grams of chlorine. What do you convert 35 grams of chlorine into? Moles of chlorine. Moles of chlorine into moles of Al. Moles of Al into grams of Al. What do you cancel out of? Grams of chlorine You cancel out of moles of chlorine. You cancel out of moles of aluminum. Is that right? That will be 1. That will be 26.98. What is the ratio between chlorine and aluminum? Is chlorine a 3 and aluminum is a 2? And then grams, that will be 70.9 and that is 1. What does this answer work out to be? That will be 2. So 6. So what is this answer, guys? $26.98. How much? 8.88. Is everybody getting this? 8.88 grams of aluminum was used up. Was used up. Write that down. What is the question asking you to solve for? How much is left behind? So what was your starting amount of aluminum? Was 10 grams. What is the amount that is used up? 8.88. So what is the amount left? Amount left equals 10.0 minus 8.88. What is your answer? Huh? 1.12. Now remember the rules for counting significant figures when we add and subtract. So how much is left behind? 1.1 grams of aluminum is left behind. What was the starting amount of aluminum? 10. Oh, I'm sorry. Okay. So is that 1.1? Okay.
1.12.
Okay, 1.12, which is 1.1. Yes.
So, I do have a question now.
Yes.
So if it's
Can I stop recording this?